Hello party people, and welcome to my session at SQL Bits. Today we're going to be talking about deadlocks. I don't know about you, but when I was a data professional, and I use that term kind of loosely, when I was a database professional, I didn't really know what to do whenever I got an alarm about deadlocks. I would get an email or something from my monitoring tool and be like, yo, you've got a deadlock. And I didn't really know what I was supposed to do about that. I didn't know how to reliably reproduce them. It seemed like they would just happen somewhere out of nowhere. And I wasn't really sure how to trigger them every time to make them happen again and again, let alone what I was supposed to do about them whenever I got those warnings. So inside the next span of the next 45 minutes, what I'm going to do is build a really simple deadlock between two different queries. I'm going to solve that by changing the query. Then I'm going to build a progressively harder deadlock using a stored procedure that ends up deadlocking itself. Then I'm going to talk about a few different ways to fix that as well. After you understand what causes deadlocks and what you should probably do to the code or to the indexes to fix it, then you're going to be bewildered about, well, what should I do? Where should I go look in my code to find this happening? And I'll show you a couple of free tools that'll make your life way easier. So let's go hop into demos and go get started. So I'm going to start here. I'm using SQL Server 2019. Everything that I'm using latest and greatest as patched as it can possibly get. But everything that I'm about to show you here has really been pretty much true since the dawn of time. I'll tell you when things veer off from different past versions. So I'm going to start over on the left-hand side by creating a couple of tables. I'm going to create a table called lefty and righty, and I'm just going to put a row in each table. So you can walk through these exact same scripts yourself. I'll give you the link too as well in your SQL Bits presentation notes. So I'm going to start by dropping this table if it already exists and go put in rows in lefty and righty. Then I'm going to start doing a transaction. On the left-hand window, I am going to start a transaction. On the left-hand window, I am locking the lefty table. I'm sure you in your life, you've never actually typed begin tran and then walked away and like dropped the microphone. But what I'm doing here is just kind of slowing down time to show you how these kinds of things happen. So the left-hand side, I've locked the left-hand table. Over here on the right-hand side, I'm going to lock the right-hand table. You'll notice I'm also doing a begin tran over here, and I'm not doing a commit. Let's go highlight that query, hit execute. And right now, things are totally okay. These two sessions aren't blocking each other. This is just the word locking, not the word blocking. There's no B inside there. It's just locking. And this can go on for forever. Let's make things a little bit more complex. Over in the left-hand window, let's go continue our transaction. And let's try to update the right-hand table. 3, 2, 1, execute. And he's not making progress because, of course, he's waiting for a lock that this other session on the right-hand side already has. He already took a lock on the right-hand side table. This is now blocking with a B. This is the thing that your users usually complain about. This session isn't about blocking, though. By default, there's no blocking timeout in SQL Server. That query over on the left is going to wait for forever until this guy finishes his work. And over on the right-hand side, we would be okay as long as the right-hand side did one of two things. If he either did a commit or if he did a rollback, either of those would be fine. To show you, I'll do one. 3, 2, 1, rollback, boom. He finishes. He also goes forward on the left. So now he on the left could go forward and commit if he wanted to. But let's go back and replay this again, and let's do it a little bit differently. Left-hand side, let's start the transaction on lefty. Right-hand side, let's start the transaction on righty. Left-hand side, let's try to go get the lock that he can't have, the forbidden lambda. Over on the left-hand side, we'll execute that. He is now waiting on blocking. He's being blocked by this guy over here. But instead of doing a commit or a rollback, let's do something different. Let's do something that is destined to fail. over on the right-hand side, let's try to go update the right-hand or the left-hand table. Now, I'm going to describe what's going to happen because things are going to move really quick once I hit execute over here. When I hit execute, I'm going to count down from 3, 2, 1. He is going to want a lock that he can't get. Whoops, come back out over here. He's going to want that lock that he can't get because Lefty already has it over there. That Lefty table's already locked over there. He down here over on this side, that Lefty is going to try to lock Righty. He's still sitting around waiting. This is now going to be a deadlock. This is going to be two queries that both have guns pointed at each other. I don't know if you've ever seen the movie Reservoir Dogs from Quentin Tarantino. If you haven't seen it, please don't go look it up now because it's terrible and awful. But for those of you who have very bad taste like I do, from Reservoir Dogs, you'll remember the scene where there are a whole bunch of people in a warehouse with guns pointed at each other. They're all bad guys and nobody trusts each other. Nobody wants to put their gun down. That's a deadlock. Nobody's willing to put their lock down. So every 5 seconds and more under certain circumstances, SQL Server's deadlock monitor wakes up, looks around, sees that we have a Reservoir Dogs standoff. SQL Server draws its own gun and puts a bullet in whatever query is going to be the easiest to roll back. Now this happens every 5 seconds, so I can't predict when it's going to happen, and I can't predict who's going to lose. So I'm going to count down from 3, 2, 1, and you'll see what happens. 3, 2, 1, execute. Query over on the left-hand side was chosen as the loser. If I look over at the left-hand side and go in, and I'm going to hit enter a few times just to kind of tighten this stuff up, it says, hey, transactions process 68 was deadlocked on lock resources with someone else, and he chose poorly. Please rerun your transaction. Then the query on the right, he's free to go. Nothing's wrong with him. He leaves the warehouse totally intact with all of the loot. He can say commit if he likes, and he's off to the races. This is a deadlock. Now what you're supposed to do, if I go look over here at this error message, what you're supposed to do in your application is you're supposed to monitor for error number 1205. And when your application gets error 1205, it's supposed to automatically try to figure out what it should retry. That's what Books Online says and has said the same thing for like 20 years. I don't know anyone who actually does that. Just like I don't know a whole lot of people who eat all of their vegetables, especially not in fried form. I just had tater tots recently. And by recently, I mean about half an hour ago. So what we're supposed to do is we're supposed to check for error 1205 and retry our code. There's nothing built into SQL Server that will retry deadlocks for you automatically. Most of the time, users don't complain about deadlocks, because deadlocks solve themselves automatically every 5 seconds. Usually they just kind of get used to it and they're like, it throws errors sometimes and it just gets logged somewhere and we got to fix it. But that's what you're here for, is maybe the application isn't handling it correctly. Your application isn't retrying the transaction later, or maybe your manager just said, hey, we're sick and tired of these deadlock errors. Why don't you go learn to do something about it? Now, the general school book kind of advice is that you should always work through tables in the same order. I don't really care whether you go parent-child or child-parent, but in all of your code, remember this is textbook, this isn't really Brent speaking, the textbook says you should work through all the tables in the same order every time you write queries. You and I both know we're lucky if our queries even compile. But setting that aside, let's see how we would go fix that simple deadlock if we work through the queries in the same order, or work through the tables inside the same order. We're going to try this again. So now this time around, I'm still going to do the same work, but I'm going to do it in a slightly different order. I'm just going to make sure that I don't have any outstanding transactions here, nothing up my short sleeves. I'm going to start the transaction on the left-hand side. I'm going to update the left-hand table. I'm going to start the transaction on the right side, but I'm not going to start with the right-hand table this time. This time, going to start with the left-hand table. I'm going to work through tables in the same order on both sides. Let's change our code. Let's go cut this and move it up to the top. So now both sides are working in the same order. The transaction on the left-hand side already started. I'm not sure if I highlighted the begin trans, so I'm going to type commit. Okay. So left-hand side, I'm going to begin tran. Right-hand side, I'm going to begin tran in 3, 2, 1. It's not making progress. But that's a good thing. That's actually, strangely, a good thing. Because this means that this query over here can't grab a lock that would stop the query over on the left. This is how you fix deadlocks. One of the ways, we'll talk about others. How you fix deadlocks, working through tables in the exact same order. Now we're back to blocking with a B. This query over here is blocked. He can't make any progress at the beginning. So the query over on the left-hand side says, party time, let's do this. 3, 2, 1, execute. It works. 3, 2. Now let me describe what's going to happen before I hit 3, 2, 1. Things are going to happen kind of quick. On the left-hand side, I'm going to hit commit when I count down. And you'll notice that over on the right-hand side, his transaction will suddenly be able to start. He'll be able to make progress because the guy on the left has gotten out of the way. Here we go. And now they both finish. Well, this guy isn't really finished yet. He just started his transaction. But now he can go on and update righty, and then he can commit. Boom. And the deadlocks are gone. Cheers all around, right? Free Guinness for everybody. Well, not exactly, because notice that we now have blocking. Now the query on the right-hand side is going to take longer because he's going to wait until the query over on the left finished. Remember the first time we did this demo, the query on the right went blazing on through, all Leroy Jenkins, and just busted his way on through because he happened to win the deadlock. This is kind of the curse of deadlocks. When you solve them, sometimes you have to solve them by introducing blocking, by causing queries to wait in order to get everything that they want before they can make progress. But in fairness, you're the one who asked me to solve the deadlocking, and I solved it. You have a different query now. That'll be $10,000 or 15 pounds, so 20 quints. I don't know exactly how y'all measure things over there. Heads, bushels, whatever it is. So that was a simple query. But now let's take a harder one, something that feels more real world. I'll close that file, close this other guy over here, and now I'm going to introduce something a little bit harder, a stored procedure. Over at Stack Overflow, when you go to stackoverflow.com, you can upvote or downvote things. I'm going to build a stored procedure against the Stack Overflow database. I'm using the Stack Overflow database licensed via Creative Commons. It's totally open source. You can go download it for free over at brentozar.com/go/querystack. And I have to say that because the kind folks over at Stack Overflow make this database available for free, and I have to make sure to give credit to them for that. So I have that stored procedure that I've written over against the Stack Overflow database, and I'm going to pretend that this is a stored procedure that upvotes things. So let's say that whoever's going to go cast an upvote in the Stack Overflow database, we want to track who cast the vote and what they were voting up. Like, you just cast a vote up on my answer because you think my answer is brilliant. I would like to take a moment to acknowledge you for thanking me. You're welcome. Whatever. It's getting complicated. So here I'm going to create a stored procedure that takes your ID as a voter. This isn't GDPR. Just leave that alone for a minute. And then whatever vote or whatever post you want to go cast it on. I start my transaction by updating your user's account. At Stack Overflow, they have a little last access date that tracks when you last did something over at Stack Overflow. So I'll start by updating whoever's doing the voting to set their last access date to right now. I'll go insert a row into the votes table to record that you cast a vote. I'll go update the score of whatever you were voting on. I'm going to go give an extra point to the question or the answer that you chose to upvote. So far, so good. Pretty simple, straightforward stored procedure. But there's a catch. Down here just a little bit lower, I'm going to touch the users table a second time. I'm going to come back and say, whoever authored that brilliant question or answer, let's go join over to their user's account and let's give them a reputation point. So for example, if you're running this stored procedure to upvote my answer, we would update your last access date, we would cast the vote, and then after we update the post to give my answer an extra point, you're also going to update my row in the users table to give me an extra point too. This would work just fine as long as two people weren't voting on each other's stuff at the same time. Let's say just by luck of the draw, because I also think your answers are amazing too. I'm going to log in and I'm going to give you an upvote at the exact same moment in time. It's like fate. It's like serendipity. You and I in a cafe sitting around upvoting each other's posts, except that's a voter ring and that's against the rules of Stack Overflow. You get the point. So you and I are sitting across the table from each other on laptops. I upvote yours, you upvote mine. We're going to have a problem in here if these two queries run at exactly the same time. Now, as much as I would love to sit around and run this over and over again until I get a deadlock, I kind of sort of value your time. If this was a 90-minute session, I might actually do that. But because these sessions aren't 90 minutes long, I'm only going to introduce in a wait for in here. No, I'm not trying to pad my session. This is just to simulate what happens when a lot of queries run concurrently. You're going to say, Brent, no one would ever put a wait for inside their code, and then I would tell you amusing stories about when I've actually found them. But my goal here is just to reproduce deadlocks quickly, even at low concurrency. I'll talk about the wait for in a second and how we might play around with that. Then finally at the end, we get a commit on our transaction down here. So let's put this stored procedure into production. Let's highlight the whole thing, put it into production, and then I'm going to run it across two different sessions. You and I, it's not you and I, it's a couple of other people, are going to upvote each other's stuff. So let's copy this and put it in a new window. We're going to run them side by side just like we did before. So I'm going to run these 3, 2, 1, execute, execute. Now, both of these queries have gathered the initial locks that they need, and they've now hit the wait for. They're getting ready to try to update each other's user accounts. And, oh, it actually happened quickly. Over there on the left-hand side, this transaction over here was chosen as the deadlock victim. Please rerun the transaction. Oh, that kind of sucks. How am I going to fix that? Well, if I go back up to the stored procedure, and one of the things that you're going to immediately say, because I know what kind of person you are, and I've seen you talk to other people's sessions, one of the first things that you're going to say is, Brent, why don't you just go remove the wait for? Let me tell you what remove the wait for really means in terms of performance tuning. What remove the wait for means is buy faster hardware, buy faster disks, index your tables better. The more that I can do to make this transaction execute more quickly, that's the equivalent of taking out the wait for. But sooner or later, you're going to hit a point where you've already invested a ton of money in hardware, or you've got the best storage that money can buy, or you're in the cloud and you've got the crappiest storage money can buy. I kid, it's a lot of money for kind of crappy storage. And you're going to have to tune it some other way. Well, what if I try to do all of the locking on the users table at the beginning? Right now, I'm doing users, votes, posts, users. What if I try to nail both of the users tables right up at the top of the query? Let's go see what happens. So I'm going to rewrite the stored procedure, kind of like a TV chef. I've already got a bun in the, I've got another version of the stored procedure. So here I've got another version of the stored procedure where I have moved both of the users table updates to the top of the stored procedure. Remember how during the simple query I said just work through tables in the same order and you're going to be fine. Well, now I'm working through tables in the same order and I'm still not going to be fine. I'm doing users, votes, posts. You'll notice that I've left in the wait for. The reason why is, again, I'm simulating crappy hardware, lots of concurrency, where it's possible for someone to get this lock and then wait for a millisecond before they get this lock, and someone else in another window has already grabbed a lock on this row. Happens at the millisecond level all the time up in production. I just don't want to sit around and wait for that to happen while I'm doing a demo. So I still have memories of my tater tots. So let's go down here and put this stored procedure into production. And then let's try the exact same thing again. Let's go execute these two in different sessions. Right-hand side, I've got this person. Left-hand side, I've got this person. 3, 2, 1, execute, execute. Have a sip of my tasty beverage, and, well, curses, foiled again. So now in this case, it's this guy over here. You can never really predict which session it's going to be that's the loser, unlike real life where we can all pretty well predict who's going to be the loser. So what I'm about to do next, is going to make you very angry. If I want to get all of the locks that I want at once, sometimes you have to write Tsql that will leave a bad taste in your mouth. Sometimes the ugly looking Tsql is actually the Tsql that works out the best. When I'm mentoring my junior developers, junior DBAs, that kind of thing, I try to teach them how to write good, clean code first. Try to write best practices ways first. But when you hit the point where best practices no longer work, you may have to do things that are kind of ugly and kludgy and that you're not going to want to see on bathroom walls. So I said we're going to work through tables in the same order. What if instead of users, what if I update both of the users' rows at once? Remember, the whole point of this stored procedure is that you, who just logged in, you're going to log your last access date, and you're casting a vote for someone else. That someone else, we need to raise their reputations. Could I write a query that in one statement, I grab locks on both of those? Well, of course I can. It's not going to be attractive. It's like most of my Tsql. So let's go take a look at that version of the stored procedure. Let's go page down a little bit further. And now I have this. I know, you're not happy about this. What we're doing is we're going to go get the posts that we're voting on, and then we're joining over to the users table saying we're looking for all the users, either the person who owns the post that we're voting on right now, or the person who's logged in and who's casting the vote. This is dirty and shameful, but it grabs a lock on both of those users at the same time. Then, up in my update statement, now, I know, I'm not proud of it either, but look, it's you go get a conference session sometime on how to fix deadlocks. It's not as easy as it looks. So here I'm saying, if the let's go set last access date as case, if it's the person casting the vote, then go update their last access date. Otherwise, don't touch it at all. Also, go update their reputation. If it's the person who owns the post, the person we want to give a free point to, then give them a reputation point. Otherwise, just leave it as the reputation they already have. Just for the sake of it, I'm also leaving in the wait for to show you that the problem is not the wait for. That's never been the problem this whole time. The problem was that we were trying to get locks on 2 different users in 2 different statements. And based on luck of the draw, not my dancing, based on luck of the draw, it's whoever happens to dive in there in between sessions that grabs a lock. That's what's causing the deadlocks. If I grab both of these locks at once, I'm going to be fine. Let's see how it works. Let's go put this into production. Let's go put this stored procedure in. And then let's go run them in 2 different windows again. Over on the left-hand side, I have user number 8741. Right-hand side, I've got 149. In 3, 2, 1, execute, execute. And now... I'd like to thank the Academy. I don't know what Academy. Over on the left-hand side, that query went through and he got by. You'll notice that the one on the right-hand side took longer. Why? Because we introduced blocking, just like we did in the simple example. We introduced blocking and let this guy get the lock that he wanted. Then he hit the wait for. This guy wasn't allowed to get what he wanted until the wait for was finished over there, thereby simulating crappy hardware, crappy storage, cloud machines, by which I mean crappy storage. So here, they're both able to finish and we're off to the races. So if I had to give you like big general advice, let's come back up to that version of the stored procedure. Here, if I had to give you like big general advice, the idea is that you work through tables in exactly the same order every time, but you also can't go back and touch tables twice. Sometimes if you're having deadlocking due to accessing the same table multiple times in a transaction, you may need to get that thing all of the locks that you need inside one statement. Or what if it's not transactional? What if you don't need both of these updated inside a transaction? Maybe you could pull some stuff out of the transaction, and that's what the last version of the stored procedure does. Here, I'm saying, I don't really care if this gets transactional consistency or not. I don't care if the vote attempt fails. Let's just go in and update their last access date because they tried to do something. Let's just set that in. I'm not as worried about the transactional stuff down in votes, posts, and users for reputation points. Seal that in a transaction. But up here, just let that finish all by itself. That will also accomplish the goal. In a perfect world, your transaction needs to be as short and sweet and only have the mission critical stuff in it. If it's not mission critical, just take it out, do it somewhere else, do it asynchronously. So now we have our general advice. We have our general advice of, here's how you go about solving deadlocking. Now we have a new problem. Our new problem is that you're looking over at your own applications and you're going, oh, sweet potato, I have no idea where to start first. I know that my code is working on all kinds of things out of order. I am certainly not getting locks across multiple rows in the same table at once. I've never written Tsql like that. I feel dirty just looking at that. So you're looking at this going, well, where do I even begin? Well, that's where things like monitoring tools can come in, but a lot of us aren't allowed to get monitoring tools, or we're not allowed to put things in place ahead of time. That's where there's a really cool stored procedure written by Eric Darling called SpBlitzLock. SpBlitzLock is totally open source, and it piggybacks on top of your extended events system default health session. Since SQL Server 2008, SQL Server's had this built-in kind of black box recorder thing with extended events. It's just tracking all kinds of system health events. And SpBlitzLock doesn't go all the way back to 2008, but it does go back to 2012. All versions from 2012 forward are supported. You don't have to install anything ahead of time. The deadlock data is already there. All you have to do is go harvest it and query it. And here's how it works. So I'm going to go run SpBlitzLock, and I'm not even going to use any parameters. There are parameters for doing things like, for example, setting up your own extended event session, and you can do this in Azure SQL DB as well, setting up sessions to go to different places on disk that then you can go and pull those extended events and deadlocks out later. SpBlitzLock returns two sets of results. The top set of result is an itemized list of deadlocks. I'll be honest, I don't go there. Deadlocks are gross. I go down to the bottom. You're not going to make a joke on that. I go down to the bottom, and down here it says, here are the tables that have been involved in deadlocks. Oh, I don't even have to do any digging. The next question you're going to ask is, well, Brent, how much data does this go, or how much history do we have inside here? And it's going to depend on your server. By default, SQL Server only keeps a limited number of rows inside the system default extended events health session. We need a catchy name for that. Only keeps a certain amount of history inside there. Since a recent cumulative update on 2016, I think it is, and newer, you actually get knobs where you can go and change that. And if you want to learn more about that, go search for Aaron Bertrand change extended events retention history, probably system health session, something to those lines. Aaron Bertrand has written a post on how you keep different amounts of data. It's a really easy change. It's not that hard. It's kind of redundant, really easy and not that hard. But down here, I can't really tell just by here how far my history goes back. You can kind of get an idea up in the top section where we're looking at the deadlock details. I got stuff going back in there to July on my particular server because it's not that active. The more active your server is, especially at throwing out errors, the more problems that you're going to have, the less you're going to see in the deadlock history. So down here, it gives me how many object deadlocks we had. You can see that lefty and righty haven't been involved in that many deadlocks. But oof, the users table on mine has been involved in 126 deadlocks. And I love this because this tells me if I'm going to go find something in terms of which tables that I need to go focus on indexing, I'm probably going to want to look at the one that has the most deadlocks on it. And if I go down further in here, there are even SpBlitzIndex commands that you can run on those specific objects. Eric, that nice guy, he's even written more info queries. So when you scroll down and you're like, I wonder what kind of indexes that table has. Does it have too many? Does it not have enough? I can go look at that with that SpBlitzIndex command. Going further, if I scroll back up to the top, it also tells me which specific indexes are involved in some of my deadlocks. Going down further, it'll also tell me who to pin the blame on. It'll tell me that this database server has had 189 instances of deadlocks involving me from Management Studio. Don't judge me, you're not the boss of me. We can go in and see which applications are involved in the deadlocks. This is so useful to me when people are like, I never query production. And then we go in there and all the deadlocks are because that bozo's in there doing begin tran, or they're running serializable reporting queries in production. I have the proof now, and I don't even have to go in and look at the deadlock graphs. If I continue to go further down, it'll also show me things like which stored procedures and queries have been involved in the deadlocks. So for example here, that USP cast upvote that we were playing around with, here we can see, here's the name of the stored procedure. There's an SpBlitz cache query to go get its plan out of the cache right now and start examining how it's written. And there's SpBlitz query store parameters, so you can go check your query store if you have it enabled to see what different versions of the plan have looked like over time. I'll be honest, that bottom section there, that's all I usually need. That bottom section down there gives me the tables, the queries involved in it, even if they're not stored procedures. If they're ad hoc queries, notice that there's ad hoc stuff down here. I get the SpBlitz cache commands to go look at their plan handles or SQL handles, assuming that their queries are still in cache, which is a gamble. They're not always in cache. That's usually all I need. But sometimes I need to look at individual deadlock graphs. And that's where the top section comes in. Bottom section is like a slice and dice business intelligence thing that tells you which tables and queries are involved. The top are the specific deadlocks themselves. So I'm going to scroll down to the end just to go look at the more recent deadlocks. And I'm going to widen these up just a little bit so that we can see them. Here, there are lines in here for every, that's not Vic, is Vic there? These are show me the victims of each deadlock and the other queries involved in the deadlock. It shows me the stored procs or ad hoc Tsql, whatever it. Who's doing that? You weren't supposed to see that. Look, I was. That's for another session. And they can be involved in deadlocks too. Isn't that neat? So there you go. So here I've got. Don't ask me why I was running dead shrink file across multiple sessions on different files. Look, my life is complicated. You can't judge me. You can't judge me. Life goes on. So here I've got stored procedures. I did not rehearse that for the record. That's kind of stunning. So here I can see the queries, or if they're not stored procedures, I can also see like our update lefty and righty. I can see the tables that were involved in each of these deadlocks. It tells me things like what isolation level the query was running on. Sometimes I'll catch people who are running in serializable isolation level because they didn't understand the defaults that they were using in .NET, or people who swear that they were doing dirty reads in production. They're like, oh yeah, I always use no lock. I always use read uncommitted. I wouldn't want to do any blocking. Well, here I get the proof. Goodness, excuse me. I can see how many transactions they have open, what their login name, what their host name is, the application that they were using. I can see whether it was a regular transaction or whether it was a user transaction or an implicit transaction for those bozos who have implicit transactions turned on. And then way far over here, I have the deadlock graph. Here's the deal. I don't read deadlock graphs. They're terrible. They're nasty, obscene, ugly. But sometimes I have to read deadlock graphs. So here's the deal. When you click on it and open it, it's not going to work the way you expect. Because SQL Server Management Studio can't comprehend that that's actually a deadlock graph. So when I click on one, oh God, XML, no! So what you do is you click File, Save As, then when you're naming it, I'm going to put it up on my desktop. I'm going to name it as deadlock graph, but you got to surround it with double quotes and then .xdl. XDL is the extension name for deadlock graphs. So when I name it with .xdl at the end, and I got to put the double quotes or else SQL Server Management Studio still appends an XML at the end of it. When I save that, I can click Save. And then I can close it, and I can burn it, and I can go out for beers. No, I click File, and then Open Recent, and it's right in here in that list. This is going to sound really stupid, I know. But you go click on it again, now that you've saved it, and oh, it's still ugly. Who wants to read this? This is terrible. This doesn't do me any good. This is where the next free tool comes in, SentryOne Plan Explorer. You may have heard of SentryOne Plan Explorer, and you think of it in terms of viewing execution plans, but it has another use too. It can also read deadlock graphs. To show it to you, I'm going to close that deadlock graph. I'm going to minimize SQL Server Management Studio, and I've opened up SentryOne Plan Explorer over here in the background. Waiting, always waiting. I'm going to go over and open that deadlock graph that I just saved. And when I open it, it renders in a circle. I don't know why they set the defaults that way. I don't know a lot of people who have circular monitors, but me, myself, I don't have a circular monitor. So I change a couple of defaults down here at the bottom. Down here at the bottom, instead of circular, I'm going to go with layered digraph. And layered digraph lays things out a little bit easier for those of us who don't have pie-shaped monitors. And the other thing you can do on big deadlocks, when there are a lot of queries involved, you can also check the box that says Optimize Layout, and that'll pull away the queries that aren't really that heavily involved in the deadlock. I don't need it here because there were only 2 queries involved. Now here's where things get kind of cool. I can hit the play button. You see the little play button down there in the corner. I can hit the play button and I get animation. You're not that impressed. I was impressed the first time I clicked on it. Okay, the other thing that's cool with this is you can click on individual things inside here because you won't understand what they are until you start clicking. And then you get, as you're clicking on it, now you get the exact stored procedure name, the exact query that was involved, the host it was running on, the application. Here's the victim's text data. Which sounds kind of weird and awkward now that I say it that way. The times when it finished, who was waiting and who was blocking. You get all kinds of really cool stuff in here about who owned the lock, who was waiting for it. This is the tool that I like to use when I have to read deadlock graphs. I don't always read deadlock graphs. I almost never read deadlock graphs. But when I have to, I find this way more useful to me because I'll just go hit play and I'll say, okay, so who got, oh, this guy grabbed something first. He took an exclusive lock, and then this other guy over there wanted the lock. All right, so what was it that this guy took here first? Oh, he tried to update the reputation of these users, and this gets me right to the line in the stored procedure that I need to start working on tuning. Love it. So now let's sum up the things that we talked about inside this session. So first, if you're the kind of person who just keeps getting emails and warnings about deadlocks and you're not sure what you should do about them, if no one's complaining, you should probably sweep them under the rug. Because now you understand that in order to fix them, you're going to have to roll up your sleeves and start changing the code or changing indexes in some cases, depending on how things work. I feel like I've only started touching the surface of deadlocks, and what you're going to end up doing is once you start using these tools, once you start using SpBlitzLock and SentryOne Plan Explorer to analyze which queries you're having that are undergoing deadlocks now, then you're going to go and start analyzing the queries and see, do I need to consistently work parent-child or child-parent? Just pick one way of applying changes to tables throughout your code. You're also going to know which tables and stored procedures you need to focus on. But you're also going to find outliers. You're going to find some kinds of deadlocks that I didn't explain here. For example, sometimes you'll have deadlocks between readers and writers, in which case it might make sense to change your isolation level. RCSI and snapshot isolation are both great ways to start solving your deadlocking problems if the deadlock is between a reader and a writer. Now, if your deadlocks are between two writers trying to access the same thing, like I showed during this session, your isolation level probably isn't going to help a whole lot. Another thing you can run into is a query that deadlocks itself. Due to parallelism, you can have what's called an intra-query parallel deadlock, meaning one query with multiple parallel tasks at the same time can try to grab locks, block itself, and end up being dead. How you solve that is also totally different, but the seed that I would plant in your mind there is when you hit that problem, search for intra-query parallel deadlocks, and that'll be the keyword that you need in order to start getting solved on that one. So thanks for hanging out with me during this session. If you're watching live, I'll be doing text questions and answers throughout the entire session. I hope to see you around at SQL Bits and see you around in other sessions. Adios.